exists today a great demand for access to precise radio determination technology, technology which is vital to both the public and private sectors. Geostar Corporation has developed that technology. For the first time ever, direct, two-way, inexpensive, and mobile access to a precise satellite radio determination service will be made possible by the Geostar Satellite System. Let's take a brief look at this unique service. The space segment of the Geostar Satellite System consists of 3 satellites plus an on-orbit spare placed approximately 35 degrees apart in the North American geostationary arc. The control segment of the Geostar Satellite System is at a fixed location at which there are Earth station antennas for each satellite and a triply redundant computer facility. Finally, there is a user segment consisting of privately owned, inexpensive, lightweight transceivers having simple dipole antennas. They will be installed in aircraft, trucks, railway cars, boats, or carried by hand. The system combines the technologies of integrated circuits, high-speed computers, and satellites. The primary purpose of the Geostar Satellite System is to provide radio determination, matching people or equipment with geographical position using the propagation properties of radio waves. The radio determination sequence begins with the transmission of a satellite interrogation signal 100 times a second at a frequency we will call F1. Upon receipt of the interrogation signal, transceivers automatically respond at a frequency F2 with a unique electronic fingerprint, a binary sequence of identifying pulses. After responding, an automatic transceiver suppression circuit inhibits further responses for a set period of time. The suppression period may be brief or lengthy, depending on the user's needs, and may even be continuous, in which case responses are made on an as-required basis. Also, the response itself lasts for just a few millionths of a second. It is this brevity of response which permits the transceiver to access the satellite without a large power source. The transceiver's fingerprint signal at frequency F2 is accurately clocked by the ground station computer as it is received. The ground station receives the fingerprint signals from the satellites through downlinks at frequency F3. The F3 signals flow from the Earth stations to the computer facility, which recognizes 3 identical fingerprint responses arriving at 3 slightly different times, correlates this information, and uses it to determine geographical coordinates of the responding transceiver. This position information is then addressed to the appropriate transceiver, uplinked at a frequency F4 to one of the satellites, and then downlinked at frequency F1, within which the interrogation signal is easily interleaved to the user transceiver initiating the radio determination request. The entire Geostar process, from request for positioning to display of precise coordinates, has taken less than 1 second, has employed frequencies capable of supporting millions of Geostar subscribers, and has provided those subscribers with direct, two-way, and mobile access to satellite bandwidth. Furthermore, this bandwidth has been greatly enriched with vital radio determination information that will find wide application in aeronautical navigation, terrestrial fleet control, emergency relief efforts, and in the battle against crime. In 1983, Geostar conducted its first field tests and demonstrations of the system for interested user groups. Present were representatives of many industries and agencies of the federal and state governments. On 4 mountain peaks near Lake Tahoe, Geostar had installed satellite emulators to carry out the electronic functions of the geostationary satellites of the full system. Several miles away, a small ground station was established. The ground station was the nerve center of the system, communicating to the satellite emulators, and, through them, to the prototype Geostar transceivers. In its very first tests, the practicality of the Geostar Satellite System was successfully validated. For the most demanding application, an aircraft was repeatedly guided to a precise landing at Tahoe Valley Airport by the Geostar system. Here we see the test aircraft, the transceiver display, and a schematic map of the area in which the tests were held. The map is a simplified version of the display that would be used by airline, corporate, or local airport fleet headquarters to track their aircraft. Similar maps would be used by surface vehicle fleet dispatchers. The map represents the Lake Tahoe test area. This is the area in which the ground station is located. Here is the lake and the airport. The black dots you see on the map trace the path of the test aircraft in real time. They're enlarged for visibility. The display is now in a waypoint mode. The pilot is being guided by Geostar to the runway center line. The directions that you see are appearing simultaneously at the ground station and aboard the aircraft. They are giving the pilot vital information, including ground speed, ground track, desired heading to the next waypoint, and time and distance to the waypoint. The aircraft has now flown to the last waypoint and is being guided by Geostar onto the final approach. At this time, the display automatically changes to the final approach mode, which provides information for the actual landing. This mode includes the same information as in a military GCA ground-controlled approach, precision landing system, but the Geostar satellite system updates at a faster rate. The line with the tick mark at the end corresponds to the localizer display presently used for instrument landings, but the Geostar display also gives the pilot his actual distance in feet to the left or right of the runway center line. In addition to information in flight, direction steers of this kind can be provided to the pilot when the aircraft is on the ground taxiing in heavy fog. This feature is unique to the Geostar system. The tests at Lake Tahoe demonstrated that the Geostar system works. In those tests, the Geostar system proved repeatedly that it can guide an aircraft moving at full approach speed to a precise landing on a runway. Tests conducted with trucks, cars, and moving pedestrians were equally successful. Currently, an airborne test facility is under construction. The satellite emulators will be flown on light aircraft at several miles altitude. As in the Sierra tests, the new facility will carry out all the functions of the complete Geostar satellite system. It will provide information on how the system works under a wide variety of conditions. It will also allow Geostar to conduct demonstrations anywhere in the country at a few days' notice. Geostar Corporation's two major goals remain as they have been since its founding: to develop the highest quality radio determination technology possible and to bring the resulting services to a wide variety of user groups at the lowest possible cost. Geostar looks forward to the continued support of both the public and private sectors as we move toward meeting these goals.